Okay, everyone, we are finishing up, wrapping up lesson 4-3. So this will be the last part, and then we're going to have a quiz on activity 4 tomorrow. So I hope you've been taking these notes down and paying attention and asking questions. So we learned a few things. We learned that if we add a k on the outside, this will move it up. If we add a k on the, if we subtract a k on the outside, that moves our parent function down. And just to recap, the parent function is this guy, right? The v that starts at the origin, okay? So adding k on the outside will make it go up, subtracting k on the outside will make it go down, and then on the inside, if we add k, that moves it to the left k units. If we subtract k on the inside, that moves it to the right k units. And then yesterday we learned about if we have a change in slope, okay? So if k is greater than 1, that's a shrink. If k is between 0 and 1, that's a stretch. And if k is negative or less than 0, then that's a reflection. So we're going to combine all those things into one solid, kind of like a formula. And so over here, I want you to ignore basically everything in this right here, okay? And we're going to use this. G of x equals a times the absolute value of x plus h. I'm just going to rewrite it with something nicer. X plus h, and then plus k. Okay, and so here's the parts. Actually, this should be minus. So a is your slope. A equals your slope. Okay, if a is less than 0, then you have a reflection. Then your graph will point down. H, the minus h, is going to be a left or right transformation, and you use the opposite of h. Okay? And then k, k is your up or down. Up or down. And it stays the same. So basically, these two, h and k, tell you your vertex. Okay? The opposite of h and k tell you your vertex. The opposite, I'm going to put a negative sign here to represent that. The opposite of h is your vertex, and then k is your y. Okay, I don't know how I did that. So here's an example. So the book starts us right here with g of x equals 2 times the absolute value of x plus 3. And if you notice, the 2 is in the slope spot, okay? And then the plus 3, we're going to use the opposite of it to give us our x for the vertex. And there is no number out here. Okay, that's a plus 0. So then our vertex is going to be negative 3, 0, with a slope of 2. 2 over 1, if you want to do it that way. I don't know what I just wrote. Vertex. Okay? So the book does quite a bit here of explaining what to do. So the first thing they do is they move the vertex over. Here's the vertex at negative 3, 0. Okay? But then we're ignoring the book's vertical stretch. We're calling it a shrink. If k is greater than 1, it's a shrink. Okay? It's going to get skinnier. So we plot our vertex at negative 3, 0, and then we use our slope to get, we treat our slope is 2, so we do 2 over 1. So we're going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And then to get the other side, we'll go up 2, left 1, up 2, left 1. And that's g of x. I feel like this is the simplest way to do it. I really feel like the book does a pretty good job of over-explaining these. So let's take a look. There are 3 things we need to notice: the A, the H, and the K. Our A is -1, so that means there's going to be a reflection since it's negative. But no shrink or stretch, okay? Just a reflection. And then our H is going to be the opposite of that, so we're going to use +1. And then our K is 2. And that is our vertex. So when I graph this one, which I'm going to do right here, okay, so 1 and then 2, so it went right 1 and up 2. So there's no stretch or shrink, so we're just going to go down 1, right 1, down 1, right 1. I'm going upside down because it's negative. Down 1, left 1, down 1, left 1. And we should get this pretty picture when we're done. And I'm done. It's reflected, and it got shifted right 1, up 2. All right, on K of X. Here's our A, here's our H, here's our K. Our A is 4, which is greater than 1, so that's going to be a shrink. Our graph is going to get more narrow, get skinnier. Our H is 1, so we're going to use the opposite. And our K is -3, it stays the same. So that's our vertex. Our graph is moving left 1 and down 3 with a shrink of 4. So I'm going to do that one over here. No reflection since that 4 is positive. Left 1, down 3. So that's going to start us here. All right, and then our slope is 4 on one side, +4, so up 4, right 1, up 4, right 1. That's the left side of, or the right side of our graph. And then up 4, left 1, up 4, left 1. Remember, it should be symmetric. It should still make a V. So starting from the origin, it went left 1, down 3, and then we have a shrink of 4. All right. And so those are some examples for you. Okay, we're doing these without a calculator. If you want to check yourself, that makes sense, but try to do it without the graphing calculator. And your assignment is going to be this is page 70, numbers 12, 14, and then you're going to do 15 through 19, so 14 through 19. And I want you to notice something down here on number 19A. Okay? So it says write the equation for each. And I want you to scratch out, stretch vertically, blah, blah. Just stretch by a factor of 5. We're going to say shrink. I'm being dumb right now. Stretch by a factor of 1. I'm going to remember what I wrote down. Shrink by a factor of 5. So we've got translate left 9, shrink by a factor of 5, and then we have translate down 23. So you're writing the equation. And then the next one, scratch out horizontally, and it's just stretch by a factor of 1/4. Okay, so this one is translate left 12 units, stretch by a factor of 1/4, and then reflect over the x-axis. And you're writing the equation. And then for C here, you're writing the equation by looking at the graph. Make sure you look for stretches and shrinks. All right, guys, make sure you upload a picture of that and turn it in. Y'all have a good day.